Au revoir. Okay, that was not hello in any language, but this lesson is going to be on polygon introduction and interior and exterior polygons. So we're going to start off with polygons. It's a brand new unit, Unit 7. And in this unit, we're going to talk about polygons and quadrilaterals. Poly meaning many, many sides, and quadrilaterals means 4 sides. So we're going to talk about many different sides today. All right. But for today, we're really going to focus on interior and exterior angles. At the beginning of this unit, okay, this unit we're going to talk about quadrilaterals, trapezoids, the different properties of parallelograms, rhombuses, and triangles, squares, and isosceles trapezoids. We're going to pretty much look at this as being a big tree, and those are the many different branches that our quadrilaterals stem from. So here's our little tree, has a little black trunk instead of a brown trunk, and it first starts off with 4 sides. All of these are 4-sided figures. These are because we're gonna talk about quadrilaterals and dive into those different types of quadrilaterals. And from that quadrilateral, we end up having 3 different kind of big main branches. A parallelogram, which anything going farther than a parallelogram, a square is a parallelogram, which is a quadrilateral. A square is a rhombus, which is a parallelogram, which is a quadrilateral. A square is a type of a special type of rectangle, which is a parallelogram, which is a quadrilateral. Same thing with a isosceles trapezoid is a trapezoid, and is also a quadrilateral. So you would keep going back up in that direction. We're not really going to talk about kites this year, but there are properties to kites, and you would be able to find different lengths using the properties of kites. Now, the quadrilateral properties, this is an important slide to refer back to because all of your properties are going to be listed right here for you to see. Now, we're going to have lessons on all of these, and we're going to have to find different side lengths and angles based off of those properties. So definitely remember maybe this number because this is a good slide to go back to because it has all of your quadrilaterals listed in one spot. All right. So for this one, we're going to go ahead and take a look at the sum of interior angles. So when we're looking at just the sum of interior angles, the one shape we did this for was already a triangle. So I know you guys can tell me some information about the triangle. We know it's 3 sides. How many triangles does it have? Well, it is a triangle. And the sum of the interior angles of a triangle, this is information you already have, is 180 degrees. Now, when we step it up and we have a quadrilateral, if it's a quadrilateral like a square, we can take 90 and multiply it by 4, and that would give you 360 degrees. So that's one way to look at it. Another way to look at it is if I drew a diagonal to that quadrilateral, notice how we have 2 triangles. And if I know that one triangle is 180 degrees and the other triangle is 180 degrees, well, all those angles added together are going to end up giving me 180 plus 180, which would give me 360. Okay, so there's 2 triangles, there's 4 sides. Now there's going to be a pattern to this, and I want you to go ahead and stop for a second. And well, we can do the next one together, and then I'm gonna stop and have you figure out what the pattern is. So for this pentagon, if we drew 2 diagonals within the pentagon, we can break it down into 3 different triangles and add all of those interior angles together. And if we were to add all of them together, or take 180 and multiply it by 3, that would give us 540 degrees. Because there's 3 triangles and the number of sides is 5. All right, so I'm going to have you pause this, and I'm also going to go on to the next slide and fill out that information. And I want you to see if there's a pattern that you can notice with the numbers or the sum of the interiors. What do you notice? All right, there could have been many different things that you noticed, and sorry, I left off on this page, but I filled in that last one. For the hexagon, that's 6 sides. Number of triangles would be 4, and it would end up being with the sum of the interior angles of 100 or 740. So you could have noticed that we were just taking this number, the number of triangles, and multiplying it by 180, and that would give us the sum of the interior. So that's a good notice. You also could have noticed that there was a pattern. As we continued to add one more side, we were also adding 180 degrees to each one. That could have been something you noticed. Another thing you could have noticed was the fact that the number of sides didn't really correlate with the number of sum of interior angles, but this number 5, 6, 7, and 8 did when we multiplied by 180. So if we were to create an equation based off of the number of sides a shape would have, we need to do something in order to get this 7 to 5, 8 to 6, 9 to 7, 10 to 8. And they all have something in common. So this number, if I just subtract 2, would become the number of triangles that are within inside the polygons. And that way we can really take a look and create an equation to find the sum of the interior angles based off of the number of sides. So if I had a decagon and I knew that it was going to end up having 10 sides, I can subtract 2 and then multiply that number by 180. So that would be 8 times 180, which would give me 1,440. So no matter what, if I knew that it was going to be a 24-agon, well, let me use a different number, sorry. A 32-agon, because after a certain amount, you no longer name them. You would just have the number and then gone, so that it would tell you how many sides that polygon has. So with 32-agon, we would just have 32 minus 2 times 180 degrees. And then so that would just end up being 30 times 180. And that's going to equal 5,400 degrees on the inside if we were to completely add up all of the interior angles. Now this is a question you guys can answer if I unblocked comments on YouTube, but I wonder what would be the interior angle of a circle? I want you to think about that. Because a circle is a polygon that has infinite many sides on the inside. So what would the interior angle be of a circle? Crazy question. See if you can get it. I have not Googled that answer. I was just wondering it just right now. Alright, so the sum of the interior angles formula. If n represents the number of the sides of a polygon, then the sum of the interior angles can be found using the formula S, which is the sum, equals number of sides minus 2 times 180 degrees. So if you need to draw a little arrow to remind yourself, hey, this is really the number of sides, okay, to help you remember what parts of the formula are, do it. Interior angle of a regular polygon. So an interior angle, a regular polygon is one in which all sides are congruent and all angles are congruent. To find the measure of an interior angle of a regular polygon, what we're going to do is we're going to take the number of sides and the sum of the angles, so this formula right here, and divide it by the number of sides. And that would give us one angle. So if we were talking about a triangle, like an equilateral triangle where all the sides are the same, what we can do is we can go ahead and take a look. The sum of a triangle we know is 180 degrees, and we can divide it by how many sides the triangle has. And when we divide that, we would end up with 60. And we've already practiced this, where one angle measure is 60 degrees on an equilateral equiangular triangle. So that would work for any of our polygons, as long as they're regular. And if it's regular, that means all the sides are the same. Alright, so we're going to go ahead and practice this a little bit. So when we're finding the sum of an interior angle, or the interior angles of a 15-agon, what we're going to do is we're going to use that formula. So the sum equals the number of sides minus 2 times 180 degrees. Plug in your information that you know. We know that there's 15 sides minus 2. So you're going to end up with 12 times 180 degrees, which is going to be 2,340 degrees. And that's going to be the sum of all of our angles on the inside, interior, because we're going to talk about exterior later on. So the sum of the interior angles of a 120-gon. So same equation. You're going to have the sum equals 21 times 2. Sorry, 21 minus 2, and then we're going to multiply that by 180. You need to simplify this before anything else, so you'd have 19 times 180, which would just give us 3,420 degrees. And that would be the sum of the angles all together. What's the measure of each interior angle of a regular polygon? So when it says each, they're only wanting one. So in this case, we're going to need to find the sum, and then at the end, we're going to need to divide it by the number of angles. Now, a pentagon, we can look back at our paper that you guys have or online, and we could look at pentagon. Pentagon is right here. If you don't remember how many sides there are 5 sides. So, with that, we can go ahead and use the formula, or use the fact that you already know how many, what the angle measure is, and then divide by how many sides there are. So that it's got 5 sides. And so the sum is going to be 5 minus 2 times 180, which is going to be 3 times 180, which is 540. I believe, yes, it's 540 degrees for the entire thing. So we would put 540 in the numerator, divided by 5. And that would just give us 108. So each angle equals 108 degrees. Alright, so what is the measure of each interior angle of a regular 18-agon? So again, we need to go ahead and set up our equation. I'm going to change color here to green. Okay, and so we have the sum equals 18 minus 2 times 180. So that's going to end up being 16 times 180. Which is 2,880, but because it's asking for each, that's the key word, of an 18-agon, we want for one of those angles. So we're going to take the number of sides and divide by the number, we're going to take the interior angle and then divide by the number of sides. So that's 2,880 divided by the number of sides, which is 18. Which is going to give us 160 degrees. So one angle measure is 160 degrees for this 18-agon. Alright, so that concludes the practice for that. Let's go ahead and take a look at exterior angles. So we did some interior, but before we do that, let's go ahead and take a look at some practice. Sorry about that. Okay, so we're going to find the practice, we're going to find the missing measure of x. We have how many sides there are. So there's the number of sides equals 4 sides. Okay, so it's a quadrilateral. We can look at our list and see that the quadrilateral has 360 degrees total for the interior angles, but if you forget that, just remember your formula is going to be S equals the number of sides minus 2 times 180 degrees. So we're going to go ahead and plug in wherever n is. So S equals 4 minus 2 times 180, which will just give us 360, because that was just showing how to find the sum of the interior angles. So once we know that all of this figure, all of these angles are going to equal 360, we can set up an equation. Much like your triangle where it's a triangle inequality. Nope, sorry, triangle angle sum theorem, where you add up all the angles and it adds up 180. This is going to be with polygons, and because it's a polygon and it has multiple sides, we have more angle measures in the inside as far as an interior sum. So this is going to add up to 360 degrees total. So what we're going to do first is we're going to go ahead and add up the other angles and subtract it from 360 to find what x is. So 79 plus 55 plus 110 is going to give me 244 plus x equals 360. So I'm going to take 360 and I'm going to subtract 244. X is just going to be 116 degrees. And there we go, we found that missing measure. That's as far as you need to go. So the only thing you need to remember is to figure out what the interior angle is, add up all of those angles, and figure out and isolate x. So let's go ahead and take a look at one more example problem, and then we're going to move to exterior angles. Alright, so looking at this, we have find the value of x. So for this, we need to first count how many sides there are. There's 1, 2, 3, 4, 5, 6, 7 sides. So with the 7-sided figure, we can go ahead and find the sum of the interior angles, which is 7 minus 2, times 180 degrees. So that's going to end up being 5 times 180, which is 900. Alright, now it's not a regular polygon, so we can't specify one angle measure, but we need to find x. So what we're going to do is we're going to add all of these angle measures together and set it up as an equation equal to 900. So let's go ahead and start there. 142 plus 150 plus, this is 90, don't forget about that. Some students overlook that. Plus 148 plus 140 plus 136. Goodness, I'm used up my room here. Let's bring this down. Come on down. Alright, well that's fine. Plus x equals 900. Alright, now ideally you can actually just add up all these angles together if you see that it's going to end up being like this, but for this problem I wanted to make sure you understood where I got that number from, because I added all of these together. So I'm going to combine like terms before I start moving anything over. And I ended up with 806 plus x equals 90. That kind of looks like a division key. Maybe I'll try to delete that there. There we go. Alright, so the next thing that we're going to do is we're going to subtract 806 to both sides. That way I can isolate that. And it just becomes 94. So x is 94 on this one. Alright. I wish I could ask you if you had any questions, but I can't. If you did have any questions, please go see Mr. Bull during tutoring, and he could definitely help you out. Let's go ahead and take a look at exterior sum angles. We've got one or two examples for that, because exterior angle sum theorem is like super easy once you understand where it comes from. So when we're looking at that, exterior angles are always supplementary to their adjacent interior angle. On the polygons below, find the measure of each exterior angle along with the sum of all the exterior angles. So whenever we're looking for exterior angles, there's a pattern that you have to extend the lines by. Okay, it's going to be the same direction on every single angle that you're doing. So in this case, it's kind of like a counterclockwise motion. So when you're finding this angle right here, mystery angle, you're going to use 79 because it's supplementary to that. Okay, so 180 minus 79 is going to give us 101 degrees. Okay, 180 minus 40 is going to be 140 degrees because these angles create a line. 180 minus 61 is 119 degrees. If I were to add all of those angles together, because it says sum, of the exterior angles, we would end up, and I'm just double checking, but I already know the answer, is going to be 360 degrees. All right, so let's go ahead and take a look on this side and see if it becomes the same thing when we're working with a quadrilateral. So if I had 180 minus 124, that would be 56 degrees. 180 minus 76, that's 104 degrees. 180 minus 89, which is 91 degrees. 180 minus 71, which is 109. Let's add all of those together. And we're going to end up with 360 degrees as well. Okay, so my question for you is, what did you notice about the sum of the exterior angles on both the triangle and the quadrilateral? Okay, and what you would have to write down, which I did not ahead of time, shame on me. Let's see if I can go ahead and bring out my, I'm going to pause the video real quick, type this out, and then I will be back. So you're going to go ahead and type out the sum of the exterior angles of any polygon is 360 degrees. Okay, so no matter how many sides you have, it's going to be 360 degrees. So I'm going to pause there for a second, and we're going to practice two problems. If you need more time writing that down, I understand, pause the video or take a look at it later. Whoops, I'm going the wrong way. Here's our two example problems. Okay, what is the measure of each exterior angle of a regular hexagon? So if I were to ask you what is the sum, we first need to start there. Because if we start at the sum of all of the exterior angles of a hexagon, or any shape for that matter, the sum would be 360 degrees for exterior. So when we're trying to find each, that's going to just tell us that it's 360 divided by how many sides are in a hexagon? 6. Okay, so then we would divide that out, and each angle on that regular hexagon is going to be 60 degrees, because 360 divided by 6 is 60. Okay, so what's the measure of each exterior angle of a regular polygon? So take the sum of the exterior angles and divide by 24. It's as easy as that. So 360 divided by 24, the number of sides, and that's going to give you 15 degrees. So each angle is 15 degrees for an exterior angle of a 24gon. All right, I hope you're doing well. If you're struggling with this and you're struggling with Khan Academy, please go see Mr. Bull. He can definitely help you out. Have a wonderful day, and I hope you have a good rest of your day. Goodbye.